A switch is anything that is used to make or break an electric current in a circuit. It consists of electrical contacts, which are metal strips inside the switch to make or break a connection in the loop. When the switch is open, the contacts are not connected, and electricity cannot flow. When the switch is closed, the contacts are connected, and electricity flows through the loop. Switches are classified based on the number of poles and throws. A pole is the number of circuits that a single switch can operate. A throw is the number of contacts a switch can change to in one circuit. To inspect a switch, we first need to take the switch out so that the terminals are exposed. We will use a multimeter on the AC voltage setting to check voltages across the switch. Make sure that the hot and ground terminals are visible on the switch. The hot terminal will be gold, and the ground terminal is green. The switch must initially be in the off or open position. Connect the red multimeter probe to the lower hot terminal of the switch and the black probe to the ground terminal. The multimeter should display a value of 110 to 120 volts for the US. Next, change the red probe to the upper hot terminal of the switch and keep the black probe on the ground. The multimeter should show 0 volts because the switch is open, and electricity should not flow across it. If there is a voltage value, the switch is faulty. Disconnect the switch and set the multimeter to the ohm setting. Attach the multimeter probes to both the upper and lower terminals of the switch. The multimeter should read O, L, or 1, which shows an open loop. Any other reading would show a faulty switch. Now we will test the switch in the on or closed position. First, connect the red probe to the lower hot terminal and the black probe to the ground. The multimeter should read 110 to 120 volts, just like when the switch is open. Next, change the red probe to the upper hot terminal of the switch and keep the black probe on the ground. The multimeter should also display 110 to 120 volts because the switch is closed, and electricity should flow across it. Any other reading would show a faulty switch. With the switch still on, set the multimeter to the ohm setting. Attach the multimeter probes to both the upper and lower terminals of the switch. The multimeter should read a value close to 0, which shows a complete loop. Any other reading would show a faulty switch. Contactors are similar to switches but are controlled electrically. They are very similar to relays, but contactors can carry huge currents compared to a relay. Relays can carry only a few amperes, whereas contactors carry up to 12,500 amperes. Contactors have higher current and voltage switching capabilities. Recall that current and voltage switching means performing the switching when the current or voltage is 0. They do not provide short circuit or overload protection, but they can break the contact if the coil excites. Contactors are typically used to connect and break power supply lines. Recall that breaking means disconnecting. They are usually used in different loads, but the complex machine controls such as motors, transformers, and heaters. The most important step before inspecting a contactor is to disconnect it from all power sources. Depending on its use, the contactor may have a few different power sources. We will use a multimeter on the ohm setting while inspecting a contactor. We should first check the contactor in the off or open position. Connect the multimeter probes to the line and lead terminals of the contactor. Recall that line and lead terminals in a single-pole contactor may be identified by L1 and T1. The contactor is faulty if the multimeter displays anything other than OL or 1, since the switch may be stuck closed. If the contactor is having more than one terminal, we should check all terminals. Next, we should check the contactor in the on or closed position. Connect the multimeter probes to the line and lead terminals of the contactor. The multimeter should read a resistance value close to 0. This is because if the switch is closed, the circuit is a complete loop. If the multimeter reads OL or 1, then the contactor is faulty. This is because if the switch is closed, the circuit is a complete loop. Make sure you check all terminals if there are multiple. Most portable heaters, like the one shown in the photo, are electric resistance heaters. Resistance heaters turn electrical energy into heat energy. Resistive heating is the process of passing current through a resistor such that it releases heat. The higher the resistance encountered, the more heat will be released. The resistive heating is governed by the simple formula Q equals I squared RT. Q is the amount of heat. I is the current flowing through the conductor. R is the resistance of the conductor. T is the time for which the current was passed. If the resistance offered is too high, no electricity passes through the material. Therefore, higher resistance may release no heat at all. Picking a suitable resistive material for a heating element is critical for maximizing heat output while minimizing energy costs. When inspecting a resistive heater, first make sure the power supply is off and has had enough time to cool to avoid burns. You can usually use circuit breakers for a larger heating unit. We will be using a multimeter on the ohm setting to check the heater. Detach all electrical wires from the terminals of the heater. This will isolate the terminals so that we can check them all individually. Connect multimeter probes across both the ends of the resistance heater. If the multimeter displays a finite resistance value, the heater is working properly. If there is an O, L, or 1, the heater is faulty. Repeat these steps for the other remaining terminals. A fuse is an electrical safety element designed to melt and separate in the event of an overcurrent. The fuse interrupts excessive current to prevent damages by overheating or fire. The electric fuse is made of a low-resistance conducting wire. The fuse wire is mounted between two conducting electric terminals. It is enclosed in a non-combustible tube. The fuse wire is made up of copper, silver, or aluminum. When an excess current flows, the wire melts, resulting in an interruption of the current flow. This prevents the electrical components from damages. When inspecting a fuse, always switch off the power supply. Check for any physical damages such as burnt marks etc. at first. A fuse is considered to be functional if it is continuous. Recall that while checking continuity, the multimeter dial must be set to the continuity setting. Connect the black and red connector to the COM and V omega port. Attach the probes across both the ends of the fuse. A long beep sound with a low resistance value indicates the fuse is functional. An OL or 1 across the fuse will indicate the fuse is faulty. Safeties in HVAC refers to the safety equipments. Some examples of safety equipments in HVAC are fuses, thermal overload switches, circuit breaker etc. Recall that fuses are the element that protects the equipment in the event of an overcurrent. Thermal overload switches are present in the motors to prevent them from damages due to overheating. Similarly, circuit breakers are safety elements that interrupt the excess flow of current. Let's learn how to inspect a thermal overload switch here. The thermal overload switch is connected in series to a power supply and a motor. In the event of an excessive heat, the switch will cut off power to the motor. In the normal state, the thermal overload switch contacts must be closed. Only after a specific temperature, the contacts must get opened. For inspecting a thermal overload switch, set the multimeter to the continuity setting. Connect the multimeter probes or clips across the 1 and 2 terminals of the switch. The thermal overload switch is working if the multimeter produces a beep sound and shows a very low reading. In the cold state, terminals 1 and 2 of the switch are connected. When the thermal overload switch has attained a certain temperature, the terminals 1 and 2 gets disconnected. The multimeter must display an OL or 1 here, otherwise the thermal overload switch is faulty. Electrical circuits are designed to handle a specified amount of electricity. Whenever the current through an electrical circuit exceeds safe levels, it is said to be an overload. This unexpected increase in current levels may be due to a power surge or a fault. The main signs of an overload in an electrical circuits are tripping of circuit breakers, shutting of other power sources, burnt marks on switches, power outlets, etc. First, turn off all the switches and unplug the appliances plugged from the circuit. Locate the circuit panel and check if any of the switches in the panel have tripped. Attempt to reset any tripped switches by turning them on and off. If turning on any of the switches trips the circuit breaker, the fixture or receptacle for that switch has a short circuit. Moreover, if turning on one of the appliances trips the circuit, there may be an overload. A circuit breaker is a switching device that can be operated manually or automatically to protect the electrical system. Recall that switches are devices used to interpret the power supply in an electrical circuit. It interrupts the flow of current, due to fault, and performs a switch's function. Types of circuit breakers include oil circuit breakers, air circuit breakers, SF6 circuit breakers, vacuum circuit breakers. Further on the basis of operation, the circuit breakers can be classified as low voltage circuit breakers, medium voltage circuit breakers, high voltage circuit breakers. Unplug or switch off all the electrical appliances connected to the breaker. Check for any physical damages such as burnt marks in the circuit breaker. Turn the multimeter on and set it to read voltage. Insert the black connector to the COM port and the red connector to the MV omega port. Attach the red probe to the terminal that feeds the power and the black probe to the ground. If the voltage reading across the breaker is either 120 or 220 volts, then it is working. If there is no voltage reading, then the breaker is bad and needs to be replaced. In this module you learned about circuit breakers. A circuit breaker is a switching device that interrupts the power supply in an electrical circuit.